math people. Today I want to investigate a very popular claim that's been circling around the web. The claim is as follows. If you take the sum of all the natural numbers, so that's the sum of all the counting numbers, 1, 2, 3, if you sum them all up, 1 plus 2 plus 3 plus 4 plus all the way to infinity equals negative 1 over 12. So this is a very popular claim that's been circling the web, mainly from Numberphile. Numberphile supposedly proved that this is a fact. It's a very popular video. Last time I looked, it had over 7 million views. 80Who also showed this proof that this was a fact. And those are two channels which I enjoy their content. I enjoy their content a lot. But if you look at this and just think logically, how in the world could I add up positive integers and that sum be a negative fraction? It doesn't seem to make sense logically. Now there are some things in mathematics which don't seem to make sense logically, which are true. Like previously we proved that 0.9 repeating is the same thing as 1. That probably doesn't make sense logically, and it's true. So we really need to dig deeper to see if this is true or not. So let's see what happens. So I'm going to show you the way they prove this is true. It's a very simple proof. And then I'll show you why the proof is absolutely false. So it starts like this. So this is what they want to prove. So they're calling this S. And this is the sum of all the natural numbers. And so let's say we don't know what that sum is. And they took another sum. So they called it S1. 1 minus 1 plus 1 minus 1 plus 1 minus 1, etc. And they wanted to find the sum of this very interesting series. Now if you look at this particular series, if I sum the first two terms, I get 0, then I get 1, then I get 0, then I get 1, then I get 0, then I get 1. So depending where you stop, the sum of all the terms is either going to be 0 or 1. So the logic that they use, since we can't determine if we stop at 1 or 0, then the sum must be the average of 1 and 0, which is 1/2. So they claim that the sum of this very interesting looking series was 1/2. Okay, we'll take that for now. We may have to revisit that later, but for now we'll take that. Then they took this other series, a very interesting series. They called it S2, which is 1 minus 2 plus 3 minus 4 plus 5 minus 6, etc. So it's like the sum of all the natural numbers, but every even term is being subtracted. So the second term, the fourth term, the sixth term, every even term is being subtracted instead of added. And so they wanted to find this sum. And the way to show to find this sum is they took another S2 and added it on to this S2. And they added it in a staggered way, which is permissible. So they put the 1 here, and a minus 2 there, the plus 3 here, and a minus 4 there, the plus 5 there, and a minus 6 there, etc., so forth and so on. So when they sum these two, they got 2S2 equals 1, negative 2 and 1, minus 1, 3 minus 2, plus 1, negative 4 and 3, minus 1, 5 and negative 4, plus 1, minus 1, plus 1, minus 1, etc. So based off this, 2S2 is equal to S1. Because when I added S2 to S2, I got S1. So they concluded that 2s2 is equal to s1. s1 is 1/2, so 2s2 is 1/2, and so if we divide by 2, then s2 must be 1/4. So far, this makes fairly logical sense. Everything is pretty good for right now. So then, they went back to the main guy we're trying to find, this guy. 1 plus 2 plus 3 plus 4 plus 5, etc. And what they did to find the sum is they subtracted s2 from this. So minus s2. Now remember, s2 is 1 minus 2 plus 3 minus 4 plus 5 minus 6, etc., so forth and so on. Now again, this is being subtracted. So s minus s2 is what we have. S minus s2. And when we subtract it, well, 1 minus 1 is 0. 2 minus negative 2 is 4. 3 minus 3 is 0. 4 minus negative 4 is 8. 5 minus 5 is 0. Right here would be 6 minus negative 6, which is 12. 7 minus 7 would be 0. Then 8 minus negative 8 would be 16. And then you would get 20. And then you would get 24. And then you would get 28, etc., so forth and so on. So they're showing that s minus s2 is 4 plus 8 plus 12 plus 16, etc. Well, what is this? This is 4 times s. 4 times s is 4 plus 8 plus 12 plus 16, etc. So they show that s minus s2 is 4 times s. And this is what they solved. So s minus s2 is 4s. If you subtract s from both sides, you'll get 4s equals negative s2. Well, s2 is 1/4. Excuse me, if I subtract s from 4s, I get 3s. You'll get 3s equals negative s2, and s2 is 1/4, so 3s equals negative 1/4, and divide by 3, s equals negative 1/12. So there it is. So the sum of all the natural numbers, according to what we just shown, is negative 1/12. That makes sense to you? You believe it? It's pretty clever. But what you witnessed was mathematical sophistry. So a lot of the claims made here were on very shaky ground. So this is absolutely not true. Let me show you why. So I want to go to the first sequence which was used, which was called S1. So S1 was 1 minus 1 plus 1 minus 1 plus 1 minus 1, etc. And it was said that this sum, so I'm talking about an infinite sum, so if I add these numbers up to infinity, it was said you got 1/2. And the claim was you got 1/2 because the sum alternated between being 0 and being 1, depending if you end off an even term or an odd term, respectively. The only thing is, for an infinite sum of a series to be a number, the series must converge. It means it must zone in on one particular number. This series does not converge. It's what we call divergence. So this series does not have a sum. This series is what we call diverges. One way we can show this, we have a test, and it's called a divergence test for the nth term. the divergence test from the nth term. And to explain it, I'll explain one property. So for a series to converge, meaning its sum is a finite number, for a series to converge, its last term should be 0. Its infinite term. So if I move it out to infinity, the infinite term should be 0. That should make sense. Because at some point I should get to 0 where the sum is not changing anymore, so hence the series converges. So if a series converges, its nth term, its term as I go to infinity, is going to become 0. Now it doesn't mean that if the nth term is 0 that the series automatically converges. That's not true. For example, here's a series. So this particular series, the nth term is 0, but this series doesn't converge. This is called a harmonic series, or a P series where P is 1. But the nth term is 0, but again the series does not converge. Now how we determine if a series converges or not, we can take the limit of the formula for each term as n goes to infinity. Like the formula for this particular series would be an equals 1 over n. So you can see, and again, each term are values when n is 1, when n is 2, when n is 3. So you can see when n is 1, I get 1 over 1. When n is 2, I get 1 over 2. N is 3, I get 1 over 3, etc., so forth and so on. If I want to see if the nth term is 0, I take the limit of this as n goes to infinity. So if you understand limits, you know that the limit of 1 over n as n goes to infinity clearly is 0. So here the nth term is 0, but the series actually diverges. So just because your nth term is 0 doesn't automatically mean that the series converges. But if the series converges, the nth term has to be 0. So if I look at this, if I look at S1, and so I want to figure out a formula to describe S1, and I'll take the limit as n goes to infinity. So I have numbers alternating between 1 and -1. So if I say an is say -1 to the power of n plus 1. So say this is the formula for this particular series. First let's see if it's a good formula. So when n is 1, that's -1 squared, that's 1. When n is 2, that's -1 cubed, that's -1. When n is 3, that's -1 to the 4th, that's 1. So you can see this obviously is going to alternate between 1 and -1. So this is a very good formula to describe this particular series. If I take the limit of this as n goes to infinity, I definitely don't get 0. Okay, the limit of this guy as n goes to infinity absolutely doesn't equal 0. So I mean, you can have some things about whether the limit exists or not, and that's a more interesting discussion, but for simplicity's sake I think we can all agree that that limit doesn't equal 0, which means this series does not converge. It diverges, so means the sum of this series is not 1/2. So that is untrue. So basically everything following that point is also untrue. But we can look at the other series which was presented, which was the series S2, where S2 was 1 minus 2 plus 3 minus 4, etc. And you can look at a formula for S2. So formula for S2, you can say an is n times -1 to the power of n plus 1. Let's see if that works. So when n is 1, this is 1 times negative 1 squared, so that's 1. Okay, that's good. When n is 2, this is 2 times negative 1 to the third power, so that would be negative 2. And then when n is 3, yeah, it's going to work. So this particular guy describes this particular series. And again, to show that the series does not converge, all I have to do is illustrate that this limit as n goes to infinity is not 0. So if I take the limit of this, guy as n goes to infinity, it doesn't take much of a knowledge of limits to see that this limit definitely does not equal 0. So this series diverges as well, and so everything that was presented to you in very clever ways was actually false. So those values for S1 and S2 were not correct values. Those are two series which diverge, so they have no sums. So if the proposition that the sum of all the natural numbers being negative 112 is not correct, so what is the actual answer? Well, let's see if this series converges. So in this series, I just had 1 plus 2 plus 3. So the formula for this series is just n. When n is 1, I get 1. When n is 2, I get 2. When n is 3, I get 3. So if I take the limit as n goes to infinity of n, I get infinity. So this series as well does not converge. And again, if I sum up all the numbers, all the positive integers going to infinity, the sum I get is going to be an infinite sum. So, sorry to break the news to you, but those nice videos you've been watching telling you the sum of all the natural numbers is negative 1 over 12 is absolutely and critically and mathematically false.